Welcome! Today we're going to learn about chain rule, and this is part of differential calculus. Okay, so before we actually get into chain rule, let's just talk about some of the basic forms of derivatives. For example, in item 1, you may have a function that's in the form x to the n. In this case, we have x squared. So that's in that form, and we know to use power rule, take the derivative, and in this case you would get 2x. In item 2, sometimes your function might be a metric function, for example, sine of x. And once you've learned the appropriate trig rules, you'll know that the derivative of sine is cosine. In item 3, if our function is in the form natural log of x, then when you take the derivative, you're going to wind up with 1 over x. And in item 4, if your function's in the form e to the x, the rules are when you take your derivative, you will also get e to the x. So the key here is when you're trying to take the derivative of a function, you want it to look like one of these forms so that you know what the rules are and how to take the derivative. Sometimes, though, things don't look quite like these forms, and that's when you generally get yourself into a mode where you probably want to use chain rule. So, what the key thing is, when you have something a little more complicated and you are using chain rule, number 1, you want to simplify the form of the function. The whole idea here is you're going to replace some of your function with the letter u. And when you do that, the idea is to simplify the form so that it now looks like something you are comfortable with differentiating. For that's something in the form, say, u to the n, which is like x to the n, or in the form e to the u instead of e to the x. Similar kind of concept here. Once you have it in that form, then you go ahead and differentiate using chain rule, and we'll get into that in a moment. So why don't we start with an example and see how this actually works. So let's say we have a function, we have y is equal to x squared plus 9 cubed. Now if you look at that function, it's clearly not in the form x to the n or e to the x or any of those other examples we spoke about. But we can make it look close to one of those forms by replacing x squared plus 9 with u. Typically, if you see something in parentheses, that's usually a good choice to take everything out of the parentheses and replace it with u. And that's exactly what we're going to do in this case. So our u is x squared plus 9. Now the minute you know what u is, I suggest you calculate u prime right away. U prime is just the derivative of u. And in our case, the derivative of x squared plus 9 using basic power rule would give you 2x. In step 2, we're going to actually rewrite our function now. So if we replace x squared plus 9 with u, our function now looks like u cubed. And u cubed is certainly a lot simpler than what we originally started with. Now we're ready to start and apply chain rule to take our derivative. So how do we do that? Well, if you look at item 3, the derivative of u cubed, remember u cubed is kind of like u to the n or x to the n, what we're comfortable with using power rule. So the first part is we're just going to take the regular derivative using power rule. So u cubed, the derivative of that would be 3u squared. And that's essentially the derivative of our function with respect to the u variable. But we don't want our answer to be in terms of u, it's going to be in terms of x. So we have to multiply this result by u prime. U prime is the derivative of u with respect to the x variable, and that's why we have to multiply by u prime. So we already know what u prime is, and we already know what u is because all that was identified in step 1. So we can now replace u and u prime with the items we have in item 1 and simplify back down. In item 5 we simplify, and our final derivative is now in terms of x, which is what we originally wanted. The substitution of u is just a temporary situation to help us take our derivative. But in the end, we want to substitute everything back because our answer must be in terms of the original variable, which in this case was x. So let's review chain rule. First, identify u, calculate u prime. 2, rewrite our function in terms of u. 3, go ahead and apply chain rule. And that's always 2 parts. The first part, take the derivative in terms of u. The second part, multiply by u prime. 4, substitute back. And 5, simplify. So let's explain a little bit more in detail why we need that u prime, okay? So let's go back to our original function. Well, we're trying to calculate y prime, and y prime is dy dx. That's another way of saying y prime. It's taking the derivative of y with respect to the x variable. That's what that means. Well, in item 2, what is dy dx? dy dx can be rewritten as dy du times du dx. And if you don't believe me, look to the right. I've rewritten it and I've used a little algebra. If you cancel the du's, guess what? The left and the right side of that equation are dy dx. So we know that this equation actually logically makes sense. If you go to item 3, it's made clear what dy du is. In our problem, dy du was 3u squared. In other words, it was the derivative of our function with respect to the u variable. And then du dx, part b, is another way of saying u prime. That's why we have to multiply u prime, because in the end, our answer must be we're taking the derivative of our function y, not with respect to u, but with respect to x. So that's why we have to invoke chain rule. There is a kind of a chain reaction event here, okay? And that's chain rule. Now go practice, practice, and practice some more.